Hi, good afternoon, everyone. This is Samad here from VBind Education Technologies, Mumbai. VBind brings industry experts live into your classrooms, and today we have a session on object-oriented programming, for which we have Mr. Angad Nadkarni joining us. Mr. Angad is nothing less of a child prodigy who started coding right from the age of 10. And so currently he is the co-founder and CTO of Hullo Inc. Before that, he has successfully founded one startup known by the name of Examify. So Mr. Angad will be will be educating us on object-oriented programming, its application, and how does it work in the real life. So without any further delay, I invite Mr. Angad to take over. Angad, just a small update. We have got Srimad Rajchandra Institute of Management joining in. We have got JIT
Okay.
Nagpur. We have got Parvati Bai from college from Pune. We have got Pimpri Chinchwad College again from Pune, and we have got Adishwar College. So these are the list of colleges who are watching you live.
Super. Can you guys hear me?
Okay. One more thing. All the colleges we have yes. So we have done the testing.
Cool.
And all the colleges are on mute so that we do not have any disturbances from the college's end. And if at all there is any problem with regards to the audio or the video, you can use the chat box which is available.
Okay. Okay. Cool. Okay. Let's get started. So I'm just going to start a screen share and then move on to my deck. Okay. Can you guys see my screen?
Yes, it is visible.
Perfect. Okay, so I'm going to get started. Yeah. So, hi, my name is Angad Nadkarni, and I've been pretty much, a little bit about what I've been doing. I started writing code.
Angad, sorry to interrupt. Can we have a full screen, please?
Okay, just a second.
Sure.
Can you still see me? Is this full screen?
Yes, it's a full screen now.
Great, perfect. So I started writing code at perhaps the age of 12. I was building small websites, etc., on front page using HTML and JS, etc. Then I moved on to writing PHP code. And by the age of 13-ish, I had developed a strong interest for computer security. I managed to get
audio option, then computer audio connected, leave computer, and you are using computer audio as a message.
Samad, am I good to go or do I need to hang?
I'm so sorry for that. A college got connected.
No problem. So do you want me to start over?
Yes, you can just continue.
Cool. So, I started doing security work and a lot of ethical hacking, etc. by the age of 13.
Hello.
Got to work with a lot of good people and subsequently raised money for Examify, which was my first venture around the age of 17 or 18. In fact, that was the time around which I joined BITS Pilani Hyderabad for my computer science. I graduated about a year ago, right? So that's just a quick, speed up about what I've been up to. And, coming more to what we have at hand today, right? What really is object-oriented programming? I'm sure most of you have either had a look at OOP before in some form or the other, be it in a Java class or be it in a C++ class, right? And a lot of times you hear these standard answers about what objects are and what classes are, right? For example, classes are blueprints for objects. That's one of the most stereotypical definitions that you will find in most computer science textbooks for classes. And at the same time, it tells us very, very little about what a class really does, right? The one definition I've sort of found very useful to refer to for objects and for classes in general is object-oriented programming is data typing on steroids, right? Objects are essentially not not any special than say an integer or a character, etc. They're all in memory. They're all programming references. And at the end of the day, all you need is a data type. All you need is the ability to create data types, right? Like you have ints, you have chars, you have strings. You have the ability to create your own data types, say like car and engine and gun and, the usual examples that you will find in most of your video games or in most of even your textbook computer science examples. So my point is to really make it sound a lot less, fuzzy from what textbooks make it sound. We're going to try and deconstruct the three things that most textbooks tell us about OOP, right? The first thing that we're told mostly about OOP is encapsulation, which is that objects let you wrap related things together, right? Encapsulation is the ability of protecting data from certain access. It's the ability to bind stuff together. It's the ability to have methods and, data members stick together, right? Encapsulation, that's the first pillar of object-oriented programming that textbooks tell us. The second thing that textbooks tell us is inheritance. Objects are extensible. You can inherit properties from a parent object. You can add functionality. You can mix and match functionality. Of course, there's a lot of limitations there, and we're going to see these as we, towards the midsection of this presentation. But the last thing that textbooks tell us about OOP, and perhaps the only thing that's actually true about object-oriented programming, is polymorphism, right? Which is the ability for a single object or a single method to respond differently to different inputs. So let's take the first pillar and deconstruct it. What really is encapsulation, right? Encapsulation is essentially being able to capsule or wrap stuff together, right? For example, think you're writing a game engine for Counter-Strike or Call of Duty or any of your favorite first-person shooter games. And you want to deal with guns, obviously, because it's a shooter. Now, the challenge with doing this without, right, in a world where you don't have objects, or where you don't have the ability to create data types, is you have to pass a lot of data members together every single time, right? You will typically see functions with 6 to 7 to maybe even 13, 15 arguments, which makes it very painful and very ugly to read in terms of code. The ability that objects give you, or rather data types give you, is they let you encapsulate stuff together. Notice that this has nothing to do with object-oriented programming. You might have used C in the past, which is largely not an object-oriented language, but structs let you do this. By the way, guys, I'm going to be using the Apple Swift programming language for most of my examples today. So the code snippet you're seeing right now is actually a Swift 2.2 example. But my point to demonstrate with this is gun in this example is not actually a class. It's a struct. It's passed by value. When it's passed into an object, into a function, a new copy of it is created every single time. It's not a pointer. It's not just a location in memory. In terms of access, it's a pass by value. It's a copy by value, not by reference. So, and it still gives you this encapsulation. So it's not just object-oriented programming that gives you encapsulation. It's data types in general and the ability to define data types that give you encapsulation. Right? Fine. So encapsulation, perhaps not such a big deal, right? Let's drop encapsulation. How about inheritance, the second pillar of object-oriented programming, right? Here we see an example of a base class called gun, which, for example, here defines a function called fire. Fire is a function that obviously shoots the gun, right? Imagine this to say render some graphics, play some sound, do that standard stuff you would expect in a video game. And what since you have so many guns and since all guns basically fire, you decide I'll subclass this into a gun, and then all my guns will child or rather extend this base class. Now, AK-47 here, for example, decides to extend gun, add a safety hatch or a lock to this gun, I'm so sorry, there's a small typo there. The if should actually say if locked, if not locked, not just if locked. But basically, the example here is trying to illustrate a usability, the reusability of code, where fire is defined only in one base class, and guns that extend it can basically call a super method called fire, which is in the base class, and not have to repeat code, right? We have one single point of failure. We have no redundancy in code. We have one place to maintain it. So this is pretty cool, right? This is something I guess only object-oriented programming would let us do. But the problem with this technique is you only have genetic development, which essentially means a class can only extend one parent, right? Now, in most real world cases, it's absolutely useless. In most real world cases, having one parent class is, if not the easiest way of writing code, it's most definitely the most unnatural way of architecting your classes in code, because most generally speaking, you will have traits or you will have properties in how you want to develop your software's architecture. So take, for example, in a first person shooter, again, coming back to our example, you have grenade launchers and you have guns. You have magnums and AK-47s, and you have all of these other guns. Now, the problem here becomes is that it's really, really hard to force all of these guns to sit in a certain inheritance or sit in a genetic development from an architecture perspective. The reality is properties and traits are a more natural way of expressing what we want to achieve with our software, right? Take, for example, the fact that yes, while a grenade launcher and an AK can both fire, a grenade launcher can also have a scope. And in fact, that logic is something it shares with the Magnum. So, where you have just one parent class and you have, multiple child classes, in that one-to-many relationship, it's very, very difficult and very, very unnatural to express what we want to attain. Okay, so we've, a lot of great software engineers have come up with this thing called a delegation pattern to solve this problem, right? Object-oriented can't let us do inheritance. Okay, no problem. I mean, rather it lets you do inheritance, but it doesn't let you do composition, right? It lets you inherit properties, but it doesn't let you compose properties together. To solve this issue, a lot of, smart people came together and proposed a delegation pattern. By the way, Apple again was the company that sort of really pushed for delegation pattern within its iOS and Mac programming manuals. But this is basically what delegation looks like, right? You have a grenade launcher. It implements a protocol or an interface for Java programmers called weapon. Why an interface or why a protocol is a question we will come to very, very soon. But for now, let's just focus on the rest of this class, right? What you see here is a scope delegate, which is used inside this object to zoom, and you have a firing delegate, which is used to fire. Why do we prefer this to extending a gun class? Quite simply put, because these delegates can be initialized and used inside any weapon of any kind. So I have no forced structure. I have no reason to extend a magnum with a grenade launcher just because I want to use a scoping technique, right? The mag and the grenade launcher can both use a scope delegate. So the delegation pattern basically gives you traits and properties that you can mix together, and you can make some really sophisticated looking object hierarchies using it, or rather the lack of hierarchies using it. Now, coming back to what the weapon interface was, right? The weapon interface, or the weapon protocol, as you call it in Swift, is nothing more than a guarantee or a contract that you will provide for an implementation for these two methods that you see here. One is on right click and one is on left click, right? Because that's how first person shooters work. You have a right click for zooming in and you have a left click for shooting your gun. So what this enables me to do is say, I'm going to focus on the application programming interface. I'm going to focus on my API. I'm not going to worry about how these methods are implemented. I'm not going to worry about which gun implements them in which flavor and in which style. I'm just going to say all my weapons, be it a knife, be it a grenade launcher, be it a magnum, all of them have a right click ability and a left click ability. And basically, a weapon protocol guarantees that to me. Now, the ability of guaranteeing things by contract is actually fundamental to what we call as polymorphism, because you essentially say, okay, I make a guarantee that you are going to be able to, use a certain trait or use a certain function, but you needn't be concerned about how it's implemented. In fact, its implementation could vary, right? Every class which implements an interface could choose to implement its methods in a very, very different fashion. So that gives you the ability to polymorph implementations and objects. And this is why a weapon protocol actually comes quite in handy, right? So you introduce a class here called hero, and what hero basically says is a hero has an array of weapons, right? A bunch of weapons that he carries. You can navigate them in a weapon wheel perhaps, and you can choose a weapon to strike with by clicking it. And you also have an active weapon, right? Now notice here that weapons could be guns, they could be knives, they could be launchers, they could be all kinds of weapons, right? It doesn't matter to me while I'm programming my hero, because it's just a protocol or an interface, right? So the ability to work with contract, the ability lets me do this. It lets me say on left click on a weapon when I don't even know what this weapon is going to be. And it lets me write code which is generic and yet supports everything that I really wanted to do. So think about just how incredibly expressive this lets me be with such few lines of code, right? Generics. I'm this is perhaps one of the greatest depths of object-oriented programming, and to do justice to generics per se would really need an entire hour by itself. But I really didn't want to close this session without having ever touched upon generics. So what generics basically let you do is they let you generify even the contract that a class is offering, or even the contract, I'm so sorry, even the contract that a protocol is offering, by saying you can actually switch the classes that it internally operates on, right? So, think about having a hero with a special move of type speciality, right? Here, all we're saying is T is a generic parameter, or a generic type rather, that implements or is based upon a class or a protocol called speciality, right? For all of the Pokemon fans in the house, this example could be easier with Pokemon. You could just say class Pokemon, and T could be one of the elemental types like earth, fire, grass and water and whatnot. So really generics basically let you say, I'm going to have a hero or a Pokemon, and I'm going to let that hero or Pokemon have a special move or a special ability. And then I can go ahead and define these whenever I'm initializing the class itself, right? So what this lets me really do is keep my base code for all of my Pokemon and keep my base code for all of my heroes the same, but at the same time give it the ability to respond differently whenever I am choosing to do so. And this really gives me a lot of flexibility as to how I'm writing my code. To see this in application, I would highly recommend you just go out online and Google for generics in your favorite language, generics in Java or generics in Swift. The best examples I can give you of generics in the standard libraries of these languages is actually with dynamic access data structures. So you look at hash tables, if you look at linked lists, if you look at queues and stacks, all of these data structures in your standard libraries in Java and Swift, or rather any language of your choice, would heavily rely on generics and type inference to actually figure out, what data type is this stack of, or is this stack a stack of heroes, is this stack a stack of guns, right? So all of that stuff actually works on generics. An array or a linked list works very heavily on generics, because a linked list can be of strings, a linked list can be of integers. So that's when generics really start to come in a big way. Dependency injections. Perhaps my favorite uh, paradigm shift in writing computer software. So interface programming is great, right? Let's in fact go back 2 slides to look at our example here, right? So hero, this is our class hero. What you'll notice now that I've conveniently skipped is initializing my array and my current weapon. Where do these values even come from, right? Take for example a car in a racing game, right? I have a class car with an engine, and whoops, in my constructor here, what you see is I'm actually going ahead and hard coding a Ford V12 engine into my car. Okay, so what is the problem with this, right? One major problem with this is now I have a slightly weird class hierarchy. I mean, yes, most cars use a Ford engine, but I really don't have to overstate that in my base class, car. Ideally, I would just want to, have an engine added into my car at a later point. I wouldn't want my car to go make an engine for itself and then install the engine for itself every time it's created. Correct? Well, this is one thing that's wrong with what we're currently doing in this example. The other major thing is, take for example, if these cars were all using one single reference to an RTO, or a database object which stored registration numbers, I would ideally want to use a single object across all my instances. And I can't do that. I can't do singletons unless I start using static members, etc. So in all sorts of ways that we think about it, this pattern of code sort of is an anti-pattern. It undoes what we've achieved with using the engine protocol, right? So, I mean, how do you test this? If you really look at it, there is no way you can test a car now without testing a Ford V12 engine for free, because you've just introduced that dependency and you've hard coded it into your class. Ideally, you want a way to test a car without having to test a Ford engine, because it's a protocol. You know that protocol is implemented. You know that it's going to do the things it does. Even if it doesn't do them, then that's a problem you have to look at when you're debugging the Ford V12 engine, not when you're debugging the class car, right? The separation of concerns is pretty much lost here because of the way the flow of control is going when a car creates its own engine. It's just not natural, right? Injections essentially solve this problem, right? But one of the useful ways I have sort of come to when it comes to explaining a dependency injection is just using the Hollywood principle, right? And the Hollywood principle is, a Hollywood studio calls you. You don't call a Hollywood studio, right? Similarly, class car doesn't call an engine. An engine sits into a car. So this is essentially what we call the inversion of control, right? What we've taken is this flow where a car came and said, I'm going to make myself an engine, to now what you see here, where an engine is being injected, right? So albeit this is a simple constructor injection, it's the simplest, it's the least sophisticated. If any of you have written enough code on Android or on Java, etc., you'll have seen Dagger and Juice, and on iOS you'd have seen Cleanse and Swinject, and there's a lot of dependency injection frameworks and libraries available out there. But this is really the simplest and basic form of dependency injection, where you inject dependencies by using constructors. Okay, so what's different in this car and the last car that we saw? Well, for one, this car class is completely independent of a Ford V12 engine. It doesn't care which engine sits inside, as long as it's guaranteeing to be an engine, right? So this works. This lets me test my car logic in isolation with my engine. It lets me test my engines separately. And most importantly, I don't really have any concern mixing between the two of them. It's appropriate concern separation between the two classes. So, of course, dependency injections and best practices for dependency injections by itself is a huge topic. One of the things I aimed to do today was just being able to touch upon dependency injections, and just to, show you as a student that object-oriented programming is great, but there's 150 ways of doing object-oriented programming the wrong way. So if you want to set yourself on the way of doing OOP the right way, dependency injections is perhaps the first place you should start looking at, because it just sort of solves all the other philosophical issues that crop up along the way when you start writing OOP. So, which sort of brings us to, okay, where are we with object-oriented code today, right? Object-oriented programming has been there for a long, long time. What's happening today? Why is it exciting? Why is it different from, just having structs? And I would say, hands down, perhaps the most amazing research work happening in the world today in the object-oriented paradigm, or in the, rather programming world, arguably from a language perspective, it's most likely Apple and its protocol-oriented programming approach with Swift. If any of you have the time, please go out and watch the WWDC 2015 talk on protocol-oriented programming. There's actually two talks there. One is on using types to build better apps on Swift, and the other talk is on protocol-oriented programming. Both are phenomenally well-made sessions, and both really exhibit what I'm about to show you. But protocol extensions basically let you massively simplify your code, right? So this is still using our delegates, and I'll explain why in a bit. But notice that we don't need to use our delegate patterns here to achieve what we're doing here, right? So I have a weapon protocol. A weapon protocol guarantees to implement a on right click and an on left click. It has a firing delegate. I have a scoper, which has a scope delegate, and it guarantees an on right click. I have the extension weapon, which defines the left click method. I have the extension scoper, which defines the right click method. And there you go. I have a Magnum sniper, which I've made by composition, right? I'm sort of implementing these two protocols, since extensions let me give default behavior to an interface or a protocol that is implemented, right? For Java programmers, this might be slightly hard to imagine. I would say, since Swift doesn't have abstract classes, it has extensions, which is in some ways the opposite of an abstract class. So instead of leaving holes in a class that you want to fill up later, what you do is you take a class and you extend it at certain parts with functionality. So in this example, what we've done is we've defined an on left click and an on right click for two things: a weapon itself and a weapon that can scope. And then I've combined these two properties to give me a really small looking class. A Magnum sniper in this case is a complete class which can both shoot as well as zoom, right? Notice here that my scope delegate and my firing delegate are injectables. Now, the advantage of this is if a Magnum happens to have a different zooming ability to a different gun or a different sniper, or if a Magnum fires differently from, say, a pistol such as a Glock, right? I can inject different delegates or inject different objects that help me do these things into my Magnum sniper, and I would have a different gun every single time, right? So that's really it. My aim was to keep this session larger for Q&A and lesser for being able to sort of just do a one-way talk with you. My hope is that I've been able to show you a couple of things that you can hopefully go home and start reading up about and follow up if you're really interested. Just to summarize, the things that we've covered are: one, object-oriented programming isn't such a big deal. Most importantly, data types can do a lot of things that objects promise to do. In fact, they've been doing it for a long while before objects even came around. The second thing we learned is that inheritance kind of sucks because it only lets you have one parent, right? Inheritance gives you genetic development as opposed to protocols and interfaces and delegation patterns, which lets you build architecture by composing traits and properties together. This is the most useful thing for app building, as you will find it in your future. Then we touched upon how polymorphism and protocol interfaces help you polymorph. We also injected dependencies using constructor injections. And we also had a look at what Apple has been doing with Swift using protocol extensions that help you build incredibly expressive code bases that express type safety as well as composition of programmatic traits, right? Uh, I'm happy to take questions now.
Okay, so let's start with the question and answer round. We'll start with Banari Aman Institute. Do you have any question? You can just ping me on the chat box and I will unmute you, or you can use the chat box itself for asking the questions. Banari Amman College, you are unmute or on unmute now. So all the colleges are on mute. Okay, I see a question coming in from Parvati Bai College. Yes, madam, we are waiting for you. Srimad Rajchandra Institute. They had a couple of questions in the previous session.
But we don't have any question.
Okay. Adishwar College, do you have any questions for Mr. Angad? PES College Pune. You can just come near the screen and ask, or you can use the chat box if you want. So the examples and the concepts taken up by Angad was very much relevant. Okay, we have got something from PES College. Angad, can you please check the chat box, or you want me to just read it out?
Yeah, I just got it. Okay, so I'm going to read out the question. How does Google make changes to code when they launch new versions to Android? Do they use any object-oriented concept for Google Android every time they're rolling out updates? Right? Okay, so that's actually a great question. So how does object-oriented architecture impact software in terms of its upgradability, right? Now at this point, I should make it very clear that I'm not a very large Android fan, and personally, I think Android is easily one of the worst architectures in the history of mankind. Let alone object-oriented programming. It is one of the most unstable platforms to ever write code on. So now that we have that, Android bashing out of the way, the way Google basically has built out Android is essentially, you have certain classes which are UI classes, and they do things that draw user interface on the phone. And then you have certain classes which are system classes, which do services and notifications and network access and stuff like that. Now, the problem with this is in terms of how phones update, right? I'm sure if this question came from somebody who's looked at Android in the past, what you will have seen is every now and then a new Android operating system comes up. It changes the way a certain user interface looks, or it changes the way a certain feature is given to the user, and bam, you have your code base that just breaks. Because you now suddenly have to inherit a different class, or you have to import some sort of support, do fallback code. Now, can this be elegantly solved by Google? Can this, compatibility entire thing be done elegantly if the platform was planned appropriately from day one? Yes. Why hasn't it been done? God knows why. If you honestly ask me, Android as an operating system came after iOS became mainstream, and they really have no excuse for poor architecture. Unfortunately, a lot of times, just to do one thing on Android, you have to import 3 or 4 different support libraries, which ideally should be happening in a base class by Google that multiplexes all of this for you by checking the phone's version. However, it remains the largest and most popular operating system on the mobile phone, so people end up using it anyway. If there are a couple of things that there are maybe one example I can share with you as to how code and object-oriented architecture breaks in an Android environment. One is, for example, when let's take, for example, list adapters on Android, right? Now, personally, my greatest problem with the way lists and list adapters work on Android is an adapter does way too much. An adapter not only does it pull data from some data source, but it also sets it into the user interface. and you see a lot of mixing there between data fetching logic and data presentation logic. Now, suppose I was to fix this because I realize it's bad planning, and suppose I'm rolling out a new version of Android to do this, what would mean is that I have to introduce new objects and new classes which solve this architectural problem, but at the same time keep those old classes, because I have millions and millions of apps that are relying on those classes. And then I have to deprecate them and eventually get them out of the system, right? So this is generally why companies like Google, are very hesitant towards making large-scale API changes on Android. But to answer your question, yes, in terms of inheritance and in terms of creating hybrid objects that figure out which version of the phone, of the OS the phone is running, and then sending messages appropriately to those classes, I would hope that Google is basically using inheritance for it. Okay, so we have another question from PS. This question comes from Siddharth, and the question is, what is the concept on which iOS security is built on? Do they also use OOP, and how is it different from Android's security? Okay, great question. I don't think the security on iOS has anything to do with OOP though. I think largely the reason iOS is said or supposed to be a more secure platform is basically because they don't let the end programmer do much with the actual operating system. I think that's a great thing. A lot of people criticize iPhone, saying it isn't as flexible as Android. But if an able to your screen brightness and switch on your screen when it wants to and record from your camera whenever it wants to, that for me is a security concern. Now the Android kernel gives you access to all of these things as an application developer by exposing objects from the system, and I will not give you that functionality. An app developer on iOS, I think until very recently in WWDC 2016, Apple has finally announced the ability to make a phone ring when you have an incoming data call. But many of you, if you have an iPhone, or if you have friends who have an iPhone, you'll have noticed that WhatsApp call, for example, on iPhone works by notifications, by repeated notifications being fired, and not by a on-screen ringer, right? So it's just in terms of the access to root hardware and the access to root functionality that Android just gives away for nothing, as opposed to Apple's approach with its kernel architecture or its API architecture, which is more defensive and it's more user thought out as opposed to developer thought out. I hope I answered your question.
Okay, I hope that answers Siddharth's question. Okay, so any more questions from the colleges who have joined in? So besides, we also have Mr. Angad's Twitter and Facebook handle here. So all the students who are not able to come up with questions right away, they can always, have Mr. Angad live on maybe Twitter or Facebook, ask the questions there. And Angad, you will be there to answer them back, right?
Absolutely.
Cool. Okay. So Angad, it was an amazing session where the students, I hope they learned about what exactly it takes to make various concepts of OOPs work in real life, maybe in gaming technology or any other technology. Thank you very much for joining in, Angad.
Thanks, Samad. Hope to see you guys soon.
Bye. Okay, so all the colleges, thank you very much for joining in, and Mr. Angad just educated us on the real world applications and the working of Android as a technology and the various concepts of OOPS which were being used. And at last count, interestingly, there were around 22,53,712 Android apps which were made, which are being made right now, and all of these are on the basics of the concepts of OOP, which Angad just covered. So let's take an example of Zomato here. So the Zomato app, which I'm sure many of them must have used, it's also being made on the concepts of OOPS. So as you move from registering yourself on Zomato app towards ordering your food, 7 concepts of OOPS are covered on the Zomato app. So let's have a screen share for Zomato. So I'm sure you must be able to see my screen. So as I mentioned, 7 concepts of OOPS are covered as you move from registration to making your final order. Now, what you can do is you can download Zomato, and you can use the coupon code as VBIND, that is WEBIND. And interestingly, Zomato is available on all the major platforms. So just download the Zomato app, use the coupon code VBIND, and you will get a 15% off on your first order. Now what to do is just make a order, get a 15% off, and by the time also learn the 7 concepts of OOPS which are being used. So this is how you can actually order your food and still learn about OOPS. Besides, Zomato is looking for various positions to be fulfilled from the engineering section. You can visit Zomato careers page or mail your resume at engineering@zomato.com. Now, once you apply for Zomato, don't forget to mention that you have already solved a real life problem of Zomato, or you do really know what concepts of OOPS are covered when you move from ordering or from registration to ordering. Besides, you also mentioned that you have a certificate by Zomato, and this is how the certificate will look like. So the certificate will have your name, Mr. Angad's name, his company name, and obviously the name of Zomato, without whom the session wouldn't have been possible. So I request all the students to go ahead, register on our website, make their profile, and download the certificate, which is absolutely free of cost. I hope this helps you in your career and in understanding what exactly OOPS is. Thank you very much for joining in. Have a nice day.